Okay, YouTube, as we wrap up looking at linear equations here and our focus on slope, we're going to look at a couple of, or at least one application of slope, and that would be as a rate of change. And so we're going to see that when we look at some real life context, the slope of a line, we can either interpret this as either a ratio or a rate. And as a matter of fact, rate is the one we hear most often, but I do want to say that it is a ratio if the x and y axis have the same unit of measure. Say like the x axis is in feet and the y axis is in feet, then a feet to feet comparison, that's actually a ratio. But when you look at something like distance per time or money per time or matter per volume here, okay, that's going to be in different units. And so we call this a rate, or a rate of change is how we'll interpret a slope here. And so one, I guess, pretty easy example to kind of pursue is this one that I've included here, but it says, say for instance, a kitchen appliance manufacturing company determines that the total cost C in dollars of producing X units of a blender is this right here. And so what we can see is that C is cost, and this is in dollars, okay, in dollars. And what we have here is X is a number of blenders. Yay, number of units of blenders. So when we look at this right here, what we're really doing is looking at a linear equation here, C equals 25x plus 3500, but that's something that could also be written as y equals 25x plus 3500, where y would, instead of C, be representing the cost here. So in this particular case, pretty easy to identify then that our slope here is 25 and that our y-intercept is 3500. And so what I want to do is really describe the practical significance of the y-intercept and the slope of this line. So to kind of visualize this here, let's go ahead and draw kind of a crude sketch, but we're going to see that on the x-axis here, we're going to say x, I'm going to label this number of units, okay? And on the y-axis here, I'm going to label this with cost in dollars, okay? And so what we see is we would get a graph here that with this 3,500, okay, being our y-intercept, would start off at a point, and I'm just going to choose an arbitrary point here, but we'd say that this is our y-intercept, so it has an x value of 0. We would start off with $3,500 here, but what would be happening is, since it has a positive slope, it would do this indefinitely, where to get to the next point here, what we're being told is that the slope is 25, or 25 over 1. So in other words, as we look at this here, let's see if I can get this in a different color, 25 over 1, we say what are the practical significances of slope and the y-intercept? We can see that the y-intercept is this point right here. And so in a tabular format, we could see that really what the y-intercept is saying is if we were to make 0 blenders, then our initial cost is just going to go ahead and start off as $3,500. And so let's go ahead and take a moment to note this here. We could look at this with a linear model. The y-intercept represents an initial quantity when dealing with linear equations. Okay, so in other words, if we have 0 something, we're already starting with $3,500 there. And then what we're going to see also is this: the slope represents the rate of change of our variable relationship. So as we look at what would happen here is if we were to continue this table, for instance, and put some more points on there, what you're going to see is every time x goes up by 1, we're going to see that we would get something like this. As a matter of fact, if we plugged in 1, we would get 25 times 1 plus 3,500. In other words, this plus, sorry, you would get 25. And if we were to make 2 blenders, the cost would be 35.50. And if we were to make 3 blenders, we would get 35.75. And this would continue to go on. And so what we're seeing is that this plus 25 right here, as we look at this plus 25, really this is a slope on our line. And when we're looking at what our y units are, this is in dollars, and what our x units are is the number of blenders, really what we're saying then is that our slope represents the number of dollars per blender that it cost. And so we can see that the slope represents the rate of change of our variable relationship. But in this specific case here, it tells us that we spend, or it costs $25 for each blender, starting with an initial cost of $3,500. Okay, so our y-intercept is our initial amount, and then that slope tells us how fast our amounts are changing as a rate. So the last thing I want to kind of point out before we tune out of this video is essentially these right here. Remember that when we're talking about lines, okay, a vertical line is always going to be any line where it's x equals a number, whereas a horizontal line, kind of backwards here, you would think it'd be x equals a number, it's y equals a number. So vertical and horizontal lines and slope-intercept form of a line here. But also point-slope form, we're always going to need point-slope form to write equations. Need to write EQs, okay? And then these final two forms you see here, the very first one, general form, is just kind of when we set everything equal to 0. We could always rearrange this by putting the constant on the other side and then getting y by itself. Or we could look at the two-point form. What you're going to see is the two-point form is the same as the point-slope form, except for instead of the slope there, they've written the definition of slope. So these are really equivalent expressions there. Cheers.